Statistics in a nutshell. Statistics. For there to be statistics, you must have topic. There must be a topic. For example, Math 1-1B students. From that topic, there is a research question. What about the topic that you are interested in? And that is when the variable is first introduced, the characteristic of the study object in the topic that you are interested in. Here it is score. Now the question is, what is the mean score? That's what is needed to be determined in that topic. Now, every question requires an answer without evidence at the moment is called a hypothesis. So, one hypothesis is saying the mean is 75%, and the other one is saying that the mean is not 75%, two opposing statements. HO is the symbol for the null hypothesis and always carries an equal sign. And mu is a symbol for population mean. Because whenever you ask a question about the population, then the symbol that is being used for that particular descriptive measure is given a specific symbol, and here the symbol is mu. Mu is a symbol for population mean. So the null is saying the population mean is equal to 75. The alternative is saying the population mean is not equal to 75. So the objective is to determine the mean score. In order to do that, you must collect data. Let us say you issue a test and you have collected the scores. Now, just by looking at that data you have collected, it will be quite impossible or very much difficult to determine the mean just by looking at the score, yet alone to be able to determine whether or not the null hypothesis is true or not. So therefore, you need to move a step further and to organize the data, that is to make it presentable using tables, most popular. Again, just by looking at the data that you have organized in tables, it will be quite difficult, almost impossible to determine the mean, yet alone to be able to determine whether or not it is equal to 75% or not. So then you move a step further to present it again using diagrams, such as a box and whiskers diagram. Now, to construct a box and whiskers diagram, we need to make a little bit of analysis. That is the calculation of descriptive measures, such as the quartiles, and to identify the lowest and the highest value. Because a box and whiskers is made of 5 numbers: the lowest value, the highest value, and the 3 quartiles. The lower quartile, the median, and the upper quartile. Now, you may or you may not be able to determine whether or not it is the mean is 75%, because you have not really calculated the mean yet. What you have done is basically calculate an average, which is the median. And the majority of the time, the median and the mean are quite different. So therefore, you need to do some further analysis by calculating descriptive measures. Now, here is a list of descriptive measures that are calculated in this course. You have the sample mean, here's the symbol for the sample mean, the median, here's the symbol for the median, the mode. The mode is not so quite popular in numerical analysis, so it does not even have an official symbol, neither the range. The interquartile range, it's abbreviated IQR. You have the sample variance, very popular, so here's the symbol for it. S squared, the sample standard deviation, also very popular. S, Spearman's ranking correlation, here's a symbol for a rho. Pearson's product moment correlation, here's a symbol for the English R. Gradient, the symbol is M, and y-intercept, the symbol is C. Now for this specific case, we are set up to determine the sample mean. The mean, in fact, the population mean. So therefore, now, we are not really required to calculate these other descriptive measures. So suffice to say, we can just calculate the sample mean. So let us say the sample mean calculated is equal to 82%. So right away now, you have to compare what the sample mean is saying with what the null hypothesis is saying, not the alternative, the null. The null is saying the mean is equal to 75. The sample is saying the mean is equal to 82. So now you are in a position to decide whether to reject the null or not to reject the null. So since 75 appears to be significantly different from 82, those two statements are saying significantly different information. So the decision is to reject the null. And the next step is to conclude. The conclusion here will be with the alternative, because it appears that it has won the debate. The mean is not equal to 75. So based on the data, the mean is not 75%. So basically, this is just a simple outline of the statistics process. And here are some key terms, descriptive measures. They are numbers calculated that are to describe a data set. A descriptive number, a number to describe a set of numbers, a set of values, a data set. Or population, a sample data set or population. And there are two main categories, statistics and parameters. Statistics are always calculated from a sample. Now, parameters, the majority of the times, are referred to a population. Most times it is impossible to calculate a parameter. Is it possible to calculate the average age of the population of the entire world? That's a humongous task. So you can only refer to that number. You can only mention the mean age of the entire world. So parameters most times are mentioned, not most times, all times are mentioned in the hypothesis. When the question is posed, it is posed about the population, and the moment you just mention a number, you hypothesized, and this number now has to be proven to be true or not using a sample number. So it's all about approximation to what is exactly happening out there. When you hypothesize it, you're hypothesizing about the population. However, to determine or not if your hypothesis is true, if it's to reject or not to reject the null hypothesis, you have to collect data from a sample. So you are using sample data to prove or disprove a hypothesis which was made about the population. They are using statistics to determine an approximate value of a parameter. So that is statistics in a nutshell.